Alright, so today, let's talk about the section we're in. We are in, let me get rid of that. Alright, the section we're in section 4.4 today, the trig functions. We have a couple new problems today that we need to cover that I didn't get to yesterday. I was hoping that we'd get to these yesterday, but we didn't. Where it's going to mix everything together. Okay, so on the particular problem we're going to do today. Okay, here we go. On the particular problem today, we have to talk about the coordinate plane. Okay, we have the coordinate plane. That is our main area of focus today. Can we draw correctly in the coordinate plane? Can we put the negatives and positives where they need to go? Now, we could cheat the system on that one, and you could use the positive-negative chart that we've talked about the last couple days. But the problem is, if you don't put the negatives in there right away, how do you know where you're going to draw it in the first place? So that's kind of the big thing here. Okay, and we're going to talk about that today. And we're also going to look at, other than the positive-negative chart, we're going to look at the Pythagorean Theorem. That was one of the things we discussed yesterday, was how to use this theorem. Actually it was even the last homework that we had to do yesterday. On the Pythagorean Theorem, we talked about how you can find a missing wall without the trig functions. That is still useful for today. And then the goal, I don't know if we'll have necessarily one right away, but at some point today we'll do an example where we'll use the special triangles. I know we haven't really discussed those for a while. I think we did maybe an example yesterday with the special triangles, but I need to make sure you have them. Now, as of this moment, does everyone have a property sheet? The cheat sheet that I gave you guys earlier this week?
I was gone. I didn't get one.
That's a misfortune. I have one.
Okay, here you go. You need one? Okay, come here. You'll need one.
That's like the one we got in geometry.
Yeah. Alright, now, Nicole, when we get to certain things, say like special triangles and the positive negative chart, there are certain things you're going to want to add to it. Okay, got it? Alright, perfect. You need to make sure you add those charts on there. Okay? Alright, now. Hey.
Oh, quit being so.
Okay, alright, today, we have a couple examples today. Okay, we have a couple examples of problems we need to accomplish today. And I want to make sure that we can put all this stuff together into like a few problems. So once we're through this first one is the one we haven't covered yet, it's brand new. Once we're through this, I'm going to try to go back and we're going to try to hit one of each type of problem that I'll assign you. Okay? That way you're kind of aware of it, you know exactly what to do in the homework. I would definitely write these notes down, just so you kind of know what you're doing and how you're supposed to attempt this problem. Okay? Alright, let's jump right into it. The first problem today, and this is it's kind of impressive the way that they have these set up. Alright, so they have tangent of beta is negative 2/3, and sine of beta is greater than 0.
I like beta.
Okay. And again, now just to go through this, and I kind of heard the comments about theta and stuff. You can actually replace the variables. I'm fine if you want to replace it with theta or something that you're more comfortable with. I know some of the times they're going to use the variable t. I don't know why they put a t in there for an angle. I've never seen that symbol used like that. You can replace those with things you're more comfortable with, like thetas or x's or something like that would make a little more sense to you. So if you're not comfortable with the way they have it, you'll definitely want to replace it before you start. Now, this problem, notice they gave me two things here. It's kind of a situation where you look at the problem and you're trying to figure out what quadrant you're in. Okay? Hold on, go sit. What are you doing? Go sit in your chair.
My butt hurts with that, so I was just...
Okay.
I understand.
Yes, fine. Okay, too much information. Just stand there. You're fine. Alright. Okay. Alright. So, the two pieces of information they give you, you have to take that information and redraw the triangle. Okay? Now, the big thing is narrowing down which quadrant you're in is the first part. This is where, like Nicole, you don't have this on your chart or on your cheat sheet.
Okay.
We need the positive negative chart.
What is that? Can you explain?
It's
Okay, all right. So So the positive negative chart is used for just telling where the trig functions, all 6 of them, you know, sine, cosine, tangent, where are they positive or negative? That's what we use it for, okay? So on this one, yeah, so I know, that was the whole point where we need to explain this, okay? This problem right here, it's telling me that tangent is negative. So by looking at just this, just the start, I know what, we have to be in 2 certain quadrants, okay? So when I draw the picture here, how I know that is tangent and cotangent are positive down here. That's where they're positive. So I'm not in that quadrant. Because I can already tell by the start of this problem, tangent is negative. So I know I'm not in quadrant 3. And I know that I'm not in the first quadrant because all the trig functions are positive here. So I'm not in the first quadrant.
You're in 2 or 4.
I'm in 2 or 4. And now when you look at the second one, this narrows down which quadrant you're in. It's telling me that sine is greater than 0. That means it's
Sine is
positive.
positive.
So it's positive. That's all that clue is telling me.
Thank you.
It's greater than 0. So that means I'm here. Because sine and its reciprocal cosecant is positive here. So I know that we're in this quadrant because tangent's negative. Tangent will be negative here. These are the only 2 trig functions that will be positive in the second quadrant. It'll be sine and cosecant. So it's telling me, so I'm not in the third.
Wow.
Because sine would be negative there. Okay, does that make sense, like how I'm narrowing this down? Now that, does that chart now make sense to you?
Yeah.
Okay, that's why we needed that chart. Again, this is a brand new problem we haven't seen yet. Now that we know that, we can draw the triangle. We know we're going to be drawing it in the second quadrant, so I'll just do a mock picture here. We're in the second quadrant, and we're going to draw the triangle where I put beta in the reflex angle spot, or the reference angle spot, I should say. Okay? So we're going to put beta right there. That's how you always set up, if you're in a quadrant, you always bring the triangle back to the x-axis. And now I'm going to set up my trig functions, and the question is on this particular problem, it wants all the remaining trig functions. It gave me one of them. It gave me tangent. Tangent's negative 2/3. But it wants all the rest of them. It wants, you know, cotangent, sine, cosecant, cosine, and secant itself. It wants all of them. Okay? So what we have to do is, now that I have my triangle, I need to plug these numbers on that triangle, where they need to go. So what does tangent actually stand for? This is the opposite wall to your angle. This is the adjacent to your angle. Opposite over adjacent. So the opposite wall is 2/3, right? Opposite over adjacent. And now notice, I left the negative sign off, correct? I know it's negative, but the problem is, you gotta know which number is supposed to be negative. 'Cause
Negative
it- Yeah, the 3 is negative, because the negative sign can go top or bottom. It looks like I put the negative on the top, but it doesn't matter. Fractions can have negatives top or bottom, it's still the same fraction. So, by knowing that it's opposite over adjacent, so I put the 2 and 3, this number is the negative one. Because in a coordinate plane, the x's are negative. And then going up, the y's are positive. So this 2 had to be the positive number, and this one had to be the negative. So they've actually tried to deceive you on this problem. This is actually one of that was in the
Why
book.
did they do that?
So you had to like move this negative sign to the bottom, because they want to get you familiar with which number is negative. So now that I have that, now I can do my trig functions, or my Pythagorean theorem to figure out the missing wall. So this is A, this is B, and this is C, so I'm going to do Pythagorean theorem. So A squared plus B squared equals C squared. This is 2 squared plus negative 3 squared equals C squared, which is 4 plus 9 equals C squared, which is the square root of 13.
Let's see what that is.
And that you can leave right here. Now, the hypotenuse will always be positive, no matter what. So even if they gave you, instead of giving me tangent, maybe they give me sine or cosine, and one of the numbers is negative, the hypotenuse has to be the positive number. So just kind of think about it that way. It could narrow down which one's negative in the first place. Okay, now if it's a weird radical, you can leave it. If you want to simplify, you can. I don't really care. I would just say leave it. You're good to go. Okay, because I'm not going to require on this first assignment that we're going to be doing here, and tomorrow I guess, I'm not going to require that you simplify them. You can just write down the answer that you get. So you don't have to worry about, moving the radical around and simplifying it down. Okay? Especially no decimals. I don't want you to type it in the calculator.
Why can't you
Never ever use
But-
decimal.
They're not exact.
Never.
Yeah, they're not exact.
Yeah.
When you type in like a square root on a calculator and gives you a decimal,
What about
that's actually just an
1.0?
approximation. It's not,
No, but
it's not
extremely
actually the right
exact
number.
approximation.
It's really close.
So
but it rounds the last
So
number
what
up.
about 1.15?
So-
That's
I mean,
pretty
this is
bad.
literally one.
What, 8 decimal places possibly?
8.0.
What about the square root
9
of
decimal
25?
places, and then it rounded probably the last number up, which is crazy. Sometimes some calculators will go on further, but it's an approximation. It's been pre-programmed to
But
be
if you
close.
take that exact number and square it, and then it, boom, it gets you 13.
Yeah, because it knows to go backwards. It knew what you're attempting to put.
It doesn't know.
So.
So, wait, if I
the
write,
square root of
hold on, I
25,
wanna
is
try
that
this
okay to
out.
write what the calculator said?
What? No, I want the exact numbers.
No, you can't.
I write this whole thing.
So you want me to write 25 and then the square root sign on the outside?
Oh, you mean like whole numbers? Is that what you're talking about, whole numbers?
Yeah, she said.
Oh,
is that
sorry.
okay to write
I thought you said decimals. Like, no decimals. You gotta give the exact. If it's 5, write 5.
Oh, okay.
Okay, sorry.
About
I thought you said decimals. Like, no decimals. I just said.
Mr.
Oh.
Ward, no, it does not know what you're trying to compute.
Oh, interesting.
It's the
So,
exact numbers to the 9th decimal.
oh, okay. So it's just.
But, that's exact. But, you take the square root of that number,
All right,
and you get
here we go.
3.65551275. Then if you clear out your calculator, put that decimal in and square it, it equals 13.
It's close.
Yeah, but why would you put that on your paper?
Why?
So-
Because I like decimals.
9 decimal places?
All right.
Page 25
Okay.
right there.
How many?
Decimal.
Hey, so here's the idea. Once we have this, we're not done yet. We have to do all 6 trig functions.
Why?
One of them is given to you. So we're going to be doing sine of beta, cosine of beta, and we already have tangent. So at least you should get 1 point on this problem because you shouldn't get tangent wrong. So at some point you better not get the 2/3 wrong, or the negative 2/3, because you know tangent. They gave you at least 1 out of the 5, and then we have to find the other ones. So cosecant, and yes, I'm writing these on purpose. They're matched up straight across from their pairing, the reciprocal pair. So cotangent should be kind of an easy one because all you have to do is flip it over. So that's kind of easy. But the idea is that 4 of them, you have to actually go find out yourself, because 2 of them kind of given. So sine is the opposite over hypotenuse, so 2 over root 3, or root 13 I should say.
Then it's root 13 over 2.
Okay, then root 13 over 2. And again, that should make sense, because the way that I have my triangle set up, that's opposite over hypotenuse, that's where I'm getting the.
Do we need to radicalize the denominator or no?
You don't need to rationalize it, you can leave it for right now.
Radicalize.
Yeah, we'll do the whole simplifying thing when we get closer to the test, because we have a couple more sections. And then the last one, and this makes sense so far, that sine and cosecant are positive, because we are in the second quadrant. So the numbers are making sense so far. And now cosine, that's the adjacent to beta over the hypotenuse. So there you go, and then we flip this over. Okay, so there you go. And it does make sense. Now, again, I'm not going to require that you rationalize the denominator or simplify it so where you have the radical off. If you can get to this point, you've already done enough work, you don't need to go further. That's a lot of steps, I know it is. You know, one of the answers is at least given to you, but look at all the steps. You had to narrow down what quadrant you're in the first place. You had to find the missing wall, given the correct numbers in the right spots. Then you had to set up your trig functions and then find what the values are and make sure that all the positive and negative signs are right. But again, the first step that I always start before I even attempted to draw was just to figure out what quadrant am I in. Like narrow it down. That way I can go from there.
Wait, wouldn't our angle be negative then?
The angle itself, the B angle, is a reference angle. So the angle beta is going from the angle beta is the reference angle for that obtuse angle. The obtuse angle is going to the, so it's not negative. It's not like we're going the other direction. So what?
I don't know what you just said.
Reference angles?
No, how you explained it.
Oh,
Well, don't worry.
it was an obtuse angle because we're getting into the second quadrant. And she was talking about why is this an angle negative? It doesn't need to be. It's just the smaller angle in that triangle. It's just acute. Yeah, that's a reference angle. They're always small.
But when you put that in your calculator, it's gonna be negative.
Well, when you type in tangent of whatever angle it is, let's say 30 degrees, it'll tell you the negative answer, okay? Because really, the angle we're working with is the obtuse one. We're working with not just the reference angle, not beta. We're actually using the obtuse when you type it in.
So we never have to find that. Yep.
That angle is something we will have to do, eventually.
It's not that
Like
hard.
to beta?
Yeah, we will be finding
You
that
gotta
out.
put the.
Then you subtract.
Not on this problem, it doesn't ask for what that angle is. Okay, we good?
Yeah.
Alright, let's do a couple more problems today, because again, this is one I wanted to talk about yesterday, but I knew timing wise, there was no way I could have covered that in
Is this
the
the one
end of
that you said
class.
you like?
So that's the one I like. That's the one.
So that's
It's
gonna be-
it's mixing everything together.
So that's
It's-
gonna be like 30.
That's a good problem. Okay, hint hint. That's a good problem.
Can I take a picture of it?
Take a picture. Okay, go ahead, fire away. I got it on the website too. All right.
What?
Hey, hey, Nicole.
Caddy?
That should be in the caddy now.
You said that you have to take them if they're not in the
Guess
caddy.
what?
Caddy.
It
Guess
won't be,
what?
it's just like,
My phone's.
Hey, put it back in the caddy. All right. Okay, here we go. Let's go through a couple more examples.
I was like, supposed to call.
All right. So, hey, let's walk through a couple more examples here. All right. Next one. All right, next one. All right. This particular problem that I'm going to give you right now. Here's the directions that they want. They want us to find the exact value for the following trig function. So they're going to give me an angle. So the angle they give me is the cotangent of negative 17 pi over 6.
What is that?
When
Yeah.
will we use this in life?
Never.
That's my
All the
question.
time.
just plug that in your
Triangle
calculator,
theory
whatever
would
you
be
do.
used in like construction or any type of engineering type of thing, because triangles are the main thing for structurally sound objects. That's why most bridges have triangular pillars when they connect. They're super strong. That's most of pre-calc and calculus is getting to that point where you're ready for. Now you could use it in businesses as well. Not like the actual construction part of it, but the actual like mathematics that are involved here. These can, because it is based on circular. So if you have
All the other.
I know it seems a little far-fetched, but if you're looking at patterns of like spending and profits and losses, that can actually be curves. They're not like rigid lines. It's like curves, like you made a little bit of money this month and it kind of flows, and you can eventually associate one of these with
Make a
it.
lot of money and never go down.
Yeah. So that's the goal, right? So, now, hey, we'll explain this whole idea of like the flowing graphs. That's the next couple sections, how we can apply it.
So why don't
So-
only construction people?
That's
We had a
not
balance
impressive.
check.
Gravity is
Why?
9.8 meters per second squared.
It's good practice, gets you higher level math.
Plug that in.
And when you're in businesses, like you're going for a business degree, you all have to take calculus in college, which is brutal. Business calculus, incredibly hard.
So I'm thinking you've taken business calculus.
I took calculus for engineers. Business is actually harder, because I saw some of the homework they had, I was like, what are you doing? It doesn't make any sense.
Probably wouldn't have it. I can do this. Probably why it didn't make any sense. But I have never learned, so I'm walking around and I'd be like, what are you doing?
Yeah. All right.
I definitely be like, what?
Hey. Okay, we got to get to this next one here. Okay. Now, to get to one of our answers here, we do have a negative, or to get to one of our questions, not answers, but one of our questions was negative angles. If I gave you a negative angle, how could we attempt to draw this? Now, negative angles are when you start on the coordinate plane and you go clockwise, I should say, from the x-axis. Now, what I need to find is what 17 pi over 6 is, and remember, that's a negative angle. So this is where it can get deceiving, because even whatever this angle is, we have to convert it and then figure out how to go backwards to go find it, whatever it is. Okay? So we have to go backwards, like clockwise.
Subtract from
to actually
360.
So,
Yeah.
okay, we can do it that way. Now, before we start, let's do a quick conversion. I believe 17 pi over 6 is not on your,
No.
so if you look at your chart, I believe 17 pi over 6 is not on here. I think we have an 11 pi over 6 is probably the highest. So,
Power 6 is around 330 degrees.
yeah, so we definitely don't have 17 pi, so we have to do a quick conversion. So when we convert this,
You know, so then you just minus
okay, so we multiply by 180 over pi, the pi's cancel. We take 180 divided by 6, I think you get 30 here.
You think?
And then you take 30 times 17, and we get a 0, 1, carry 2, 510 degrees.
Jeez.
That's a lot of
Degrees.
That's a lot of degrees.
A lot of degrees.
That is like twice.
Now, one of the things I heard, Reese, you actually said, what was the thing you said earlier?
Subtract from 360.
Exactly. Actually, we're going to subtract 360 from this.
Oh, never mind.
The reason why. Now, again, this is a negative angle, so we're doing cotangent.
Shut up, Squire. I will hurt you.
All right, hey, cotangent of negative 510. Okay, that's a very, very big angle. So what we need to do is we need to subtract 360, or technically add 360. We need to bring this back to where it's smaller numbers, because right now, this is bigger than one full loop, right?
Oh, yeah.
360 is a full loop, we're past that. So we're actually like, my drawing wasn't even accurate. We're already past 360, and we're going again. And so what I need to do is figure out, smaller numbers. So you can do coterminal, right? This is a negative 510. So what you can do is you can add 360 to it, and that will bring it back down to something smaller. And I know like adding 360 is kind of weird, but those are coterminal angles, right? They line right on top of each other if I spin circles. So if you add 360, what do we get?
You're gonna add 360,
Negative
negative
150.
150.
Negative 150. Okay. So what that means, if we're doing this, negative 150, that means we did a full loop, and we're going this direction, and we're going to stop at negative 150, which is here. That's a negative 150. How I know that? This would be negative 180, so we're not quite to 180, we're down here.
30 degrees.
So we're in the third quadrant. This is pretty much what I needed to figure out. I need to figure out which quadrant we're in. You're in 3. All that math, just to figure out we're in the third quadrant with a negative 150. So, now that we know this,
I think that would be easier.
Do you think that would be easier, Justin?
so,
Well, it's not.
now that we know that this is a negative 150 for a degree, that means the difference between that and 180 is 30 degrees.
Oh, yeah?
So, and again, I'm using positive, I'm not using negative, I'm using a positive angle there. That's my little reference angle inside the triangle. And now we're using the special triangles, the 30, 60, 90 triangles. Okay? So, this is the part, Nicole, you want the 30, 60, 90 triangles and the 45, 45, 90 triangles. You need that on your property sheet as well.
Okay.
So, okay. Now, the 30, 60, 90 triangle, the side opposite of 30 is 1. The side opposite of 60 is root 3. And the side opposite of 90 is 2. Now, I do know that I have to fill in some negatives here, because it is in that third quadrant, so I do have to fill in some negatives.
Plus negative 2 equals positive down.
Negative root 3, negative 1. Because I'm going to the left from the origin. This is the origin, by the way, that's 0, 0. So I'm going to the left, negative 3, down, negative 1, and the hypotenuse is always going to be positive. So now what I can do is now that I have all the numbers in my triangle set up, now I can actually find the question that they want. They want the cotangent of negative 510, which we just said a little bit ago, that is the same as the cotangent of negative 150, which is the same as doing the cotangent of 30, because that's the reference angle that's inside my triangle. They're all the same answer. Now, I know that the difference would be positive and negative signs, but we're in the third quadrant, right? Cotangents can be positive no matter what. We're in the third. Tangent and cotangent are positive. So I know my fraction, my final answer for whatever this thing is, it's going to be positive. I know that before I even start. But now all I have to do is think about what does cotangent mean? Well, instead of doing tangent, we're going to do opposite over adjacent. We flip-flop.
Adjacent over opposite.
Adjacent over opposite. Now, I know both numbers were negative, but the negative signs would cancel,
So it's irrelevant.
so it's positive. Okay, questions on that problem? That's my answer. That's what I was looking for. I was looking for this answer.
Negative of, oh.
That.
You have a positive.
Can't we just simplify that?
Now, I don't want the decimal of it. Like, I know the square root of 3, 1.7, blah, 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 blah. Okay.
Do you have to write that?
Isn't it just square root?
You can just write it root 3, it's fine. I don't require that you simplify them. You can leave them a fraction, and you don't need to worry about moving the radical
Can
around
we
or
make it a
afterwards.
decimal? if we
Well, I
want?
mean, that one.
Preferably no. I want the exact
When
answers.
it's over 1.
No decimal form.
There's
No decimal
still the
approximation.
exact answer. I'm sure if I take that number and I square it, I'll get 3 all day of the week.
I know. The calculator is rounding the number off and saying it's 3, because it's probably 2.9 repeating when you
I'm gonna
actually
write this
square it or
8-digit
whatever.
decimal down. I'm gonna square it.
Alright. All right, questions on the types of problems I've given you today. Now, this is one that was new. It wasn't like the last couple. We did something like this yesterday. I just didn't pick a crazy angle like that. The only reason I picked it is because the question was about negative angles. I want to make sure you got to see one of those. All right, I have one more problem today and then we're done. One more. So, that was a weird noise. So, all right, here we go. All right. That was so weird. Okay, here we go. Last problem of the day.
It's so hard.
Okay, find the value for all 6 trig functions. All right, now, this is, I'm gonna abbreviate, I'm gonna stop here. This, all right, this is our main goal today, is figure out all the 6 trig functions. Now, there is some more explanation in the directions above. It does say that we're on a unit circle, that you're on a coordinate plane, and that your angle is theta, and that's your reference angle, okay? So, the idea is that what they're gonna give you on this particular problem, this is an example, we did something like this yesterday, they give me something like this. That's all they give me. They give me a coordinate. And what you need to do is, knowing that this is on a, on a unit circle.
That's a cosine sine thing.
What was that?
Cosine sine is what I said.
Yeah, so you, that in theory, yes, you could do it that way. But hey, I don't want you to actually just say that cosine is 2 and sine is 2. I don't want that.
I like
Because the idea is that I don't want it to automatically be put, I want you to draw this in the coordinate plane, like this, where you're going to draw 2 over, 2 up, and when you draw your line connecting to that spot, I want the right triangle in here, where this is theta, and I want you to set up your triangles using this, okay? Where this is 2, this is 2, and this number is the missing number, which we need to find here in a minute.
Is it 45?
The angle's
Okay.
45.
Yeah, the angles are 45, so we can do the whole special triangle in that. But if you didn't recognize that, which I'm really happy you guys did, if you didn't recognize that, you would need to do the Pythagorean Theorem, which I know that in the end it's going to be 2 root 2. But anyways, how you do this, you do 2 squared plus 2 squared equals the hypotenuse squared. Because again, these are my A and B's. This is 4 plus 4. C squared, which is 8. And then you take the square root. Now, like I said earlier, you do not need to simplify that radical.
We could.
You could, I don't require it.
2.8.
Okay, so this is your square root of 8, which is 2 root 2. Now you can set up all your trig functions from there. Now, the main difference here, like why some people are saying, well, isn't that just cosine and sine? It's different than that because they want you to draw it in a rectangular coordinate plane as opposed to directly putting it on a unit circle. Because here's the thing, how I know it's not cosine sine. Look at the length of that stick. Look at the length.
It's not 1.
Yeah, it's not 1. It's not 1. When I go over 2 and up 2, the length of that ray, the hypotenuse, isn't 1. It's actually, Reese, what was the number you said earlier, that weird decimal?
It's 2.828427125.
The hypotenuse is definitely not 1. So that means if this isn't the number 1, then this isn't cosine and sine. They're close. They're just not that exact number. Because it's not a unit length of 1. If it was 1 in length, like if I shorten this up, then yeah, that would have been cosine and sine perfectly, because you guys know the drill how that worked. But that's why I gave you this problem. So we have root 8. Now we can figure out all the trig functions from this angle right here. That's my angle. So I'm going to do sine, cosine, tangent.
How come the teacher's wearing jeans?
It's
The staff appreciation
yeah,
day.
staff appreciation.
Mr. Ward, I appreciate
He
you.
made a speech about you.
So
Have you watched the speech yet?
I have.
Did you enjoy
I
it?
did. I added it to my website, definitely.
I saw it.
So I gave you credit for it.
You don't have it.
All right. Hey.
Tell that it was me.
Okay. So So on the sine of theta, on sine of theta, you're going to do the opposite over hypotenuse, so 2 over root 8. Now, are any of those numbers negative?
No.
Absolutely not.
You're in the first quadrant. Nothing's going to be negative. Cosine is going to be adjacent over hypotenuse, so 2 over root 8.
We should
And then tangent is opposite over adjacent, that's 2 over 2. And then to get to the other trig functions, the reciprocals, you just flip those over. So to get to the reciprocals, you would go cosecant. That's the reciprocal of sine, because remember, every trig function is paired with one that starts with letter C. So this is root 8 over 2. And hey, don't write that as root 4. You don't divide those, by the way, because one's a radical, one isn't. And then on the second one here, this will be secant, which is root 8 over 2.
Isn't root 8 over 2 the same as 2?
Yes, because.
Or like root 2?
It's root 2. Yeah, they would simplify. And then cotangent
Which is
is
1.41.
But we don't have to simplify those?
no. I do not require on this homework that you have to simplify
What
any
about on
problem.
the test?
So we can write.
Test will eventually get
We
there.
should put
Yeah.
them all into decimals.
On the test, there will be problems that will want you to simplify, but I'll tell you which ones.
We just know.
Okay?
That's why
Because I consider these to be hard enough as it is. Okay? Okay, you have about 5 minutes left of class here. Make sure tomorrow that you bring your textbooks tomorrow. I know that tomorrow we're going to do a pep rally in the morning.
What?
Pep rally because all the winter sports are coming to a completion, so they always try to.
Basketball's not like a
We
month
still got like
left.
a month left.
Yeah, but they're coming down and they want to at least have at least one pep rally before then. So I know they're going to be acknowledging basketball,
Brett did say
wrestling.
you got the honor.
They're going to be acknowledging the Special Olympic athletes. So we have a lot of things going on.
No,
So.
he said this. He also
Right
got
away
the
in the morning?
qualified.
Yeah, it'll be right at like 8:20 tomorrow.
When's
8:25.
He told me he dreams about running in his
This
sleep,
one?
but he still reaps the
Middle one.
benefit of running. So he just thinks about it.
Okay, hey, now my period 9 classes, I won't be there tomorrow. They may ask for help. Don't be afraid to help them out. I have a video for them that will be different than the video you guys have because I'll try to explain a little more to them. But they may need some assistance tomorrow. I don't know because we went through everything you need. Just if they need help, they ask you questions. Don't be afraid to help them because I'm not here tomorrow. So please help them out.
Mr. Ward, me and Reese are gonna tell him that you would like everything in decimal form.
Don't do that.
We should do it all in decimal. It's just so much prettier.
I don't
I agree.